box with a square base and open top. X height. A box with a square base and open top must have a volume of 32,000 cubic centimeters. Find the dimensions of the box that minimize the amount of material used. Minimize surface. This is what we're asked to find. One more time. A box with a square base and open top has a volume of this. Find the dimensions of the box to ensure a minimum amount of material used, which means a minimum surface. Okay. So first of all, I look at the volume, and I know that the volume of such a box is area of the base times the height. So volume is area of the base multiplied by the height. In order to find a minimum, I need a function. I need to create the function that is the surface of this box and find its minimum. Okay, so let's see how we write the surface. I'm going to call it S. At this point depends on two variables, area of the base, x squared plus 4 sides, 4 base times height. I can have a function of two variables, but from here, from this equation, where I have 32,000 equals x squared, which is the area of the base, times the height. Solving for the height, I get 32,000 divided by x squared. And I am going to replace it in here. And now I can say, yes, I'm happy. I have a function of only one variable. I have the x squared, I have the 4x, and I replace h by 32,000 over x squared. I simplify as much as I can, and I get x squared plus 4 times 2 is 8, and 4 times 3 is 12 over x. The problem is almost solved. How come? I have to find s prime. 2x minus 128,000 over x squared. Please remember that 1 over x prime, I need this in the next chapter, is negative 1 over x squared. We wrote this several times. Okay. I have to find the LCD, which is x squared. I need to multiply this by x squared, so I have 2x to the third minus 128,000. Critical numbers do not come from the function being undefined because x cannot be 0. But they come from the function s prime being 0 when the numerator is 0. 2x cubed minus 128,000 equals 0. Yes, I'm going to divide by 2. I get x cubed equals 64,000. Nice. And I get x equals 40. And that's in centimeters. So I claim that this gives a minimum. Absolutely not. You should not accept that. You should say show that x equals 40 gives a minimum s of x, because you have to show that. And I will definitely show it. S prime 0, 40, infinity, that's not possible, but 0, this is always positive, but if I plug in 0 in this function, I get negative. And if I plug in 100 in this function, it will overcome this. So it'll be positive. So I showed you that this gives a minimum. Is it done? No. I'm asked to find the dimensions. I only found the side of the base. I didn't find the height yet. So that's okay. I just want to have to go back and replace it in h. So h equals 32,000 divided by 40 squared. And I simplify, and I get 20. So the dimensions that give the minimum surface area are base 40, side of the base 40, height 20. If they ask us to determine that, we can. So S of x, I'm just going to copy it here so I have it. X squared plus 128,000 over x. And I will plug in 40 and see what I get. I'm lazy. 40 squared plus 128,000 divided by 40. 4,800 squared centimeters. Min surface. And this is your first optimization problem. Well done. Any questions? Any questions? Can I choose the next one?
Yes.
Any questions on this one? So what we did, we created a little figure. We wrote what we were given, the formula for the volume of such a box, and identifying what we're asked to find. And we're asked to find the minimum surface. Actually find x and h for the minimum surface. We needed to create a function, and we did. It has to be a function of one variable in this class till Calc 3. Also, we found S prime. We found the critical numbers. We put them in the table so it showed just this, to show that it gives a minimum. And then we determine the minimum if they are asking us to find it. Okay. So let's take a look at the, so that was a volume situation, volume surface area situation. Let's look at what I call a poster problem. Poster problem. Okay. So there are two problems here that I see. The top and bottom margins of a poster such and such, and the poster is to have an area of such and such. It doesn't matter to me which one we look at. If you like to choose, I can wait for you to choose, but I don't want to waste too much time in choosing.
Whichever.
Okay, let's do 34 then. Okay, so a poster is to have an area of 180 squared inches. 1 inch margins at the bottom and sides. One inch bottom and sides. Two at the top. Okay. What dimensions will give the largest printed area? what dimensions will give the maximum printed area. Okay. So I have to start with the printed area. So I have to determine a function. That's my starting point with the area that it's considered in the middle of the poster as being the printed area. Okay. Now, I don't want these two to be confused. So I'm going to call AP. So the area for the printed portion, and this is the total area, if you want AT. Okay, so this dimension will be X, but also two pieces, left and right. So what is this measure?
X plus 2.
Great job, thank you. What about this? Excellent. Okay. So the total area, which is 180, is the same with X plus 2 multiplied by Y plus 3. Do you agree so far with this? So the total area of the poster is base times height, X plus 2 times X plus 3. Okay, I have, this is my target, but I have two variables in here. I can't have two variables. So this equation will help me eliminate one of the other, one or the other, one of the two. Now let's see what we get. And from here, I will solve for either X or Y, whichever it's easier. So 180 equals X times Y plus 2Y plus 3X and plus 6. So this is XY plus 2Y plus 3X, and I move 6 to the other side, and I get 174. I'm going to solve for Y. I pull out Y. So I have Y times X plus 2 equals 174 minus 3X. So Y equals this. And I would put it in now. Finally, it's a function of X alone. And I have X times 174 minus 3X over X plus 2. Or negative 3X squared plus 174X divided by X plus 2. So the biggest step here was to find the function. From this point on, this should not be give us any difficulties. We have to differentiate, we have to find critical numbers, we have to study the sign and make sure that that gives the maximum. And check, show that. It's done, right? So let's come back and see what we did before we finish it up. So we created a graph or a figure that showed the area of the printed area, the sides, that are the borders, if you want, of the printed area. We knew that we were interested in finding the maximum of this function, which is X times Y. We know that we are given the function, the total area, which was 180, which is X plus 2 times Y plus 3. From here, with algebra, we finally got Y. We distributed. I'm also checking and make sure. So I subtracted 6 and I get 174. And then I factor out of Y and subtracted 3x, and that's it. And now I went back to the printed area, x times y, and I replaced y by what I just obtained, this putting in descending order. You can say, yeah, I would like to remove that negative sign, and I will have to agree. And then I will differentiate. So a prime of x, top prime, 6x minus 174 times x plus 2 minus 3x squared minus 174x. Luckily, the denominator prime is 1 over x plus 2 squared. Do not get tempted to do anything, any simplifications here. Be careful. I will have to distribute and see what I get. So 6x squared minus 174x plus 12x minus 174 squared is 348. Please watch my numbers. I'm not trying to see whether you were asleep or not. No. I'm lazy when it comes to the calculator for some reason, sometimes, so I think I'm okay. 34 is correct and that. Okay, minus 3x squared plus 174x. I'm so happy to see this going away. And then I have negative, and this is 3x squared plus 12x minus 348 over x plus 2 squared. Good. So this is never undefined because x cannot be negative 2. That's not possible. So it could be 0, which means 3x squared plus 12x minus 348 is 0. And where's my old calculator? Okay, second and poly, and the order is 2. And the coefficients are 3, 12, and negative 348. Negative 348, give me the solutions. Okay, it gives me a negative solution, which I would have to disregard. So it gives me 8.95. And the measurement unit, inches. Now I have to determine y. So y equals, and I'm going to use parentheses, 174 minus 3 times the previous answer, close the parenthesis, and divide by parentheses the previous answer. I didn't put it in. I determined it differently. So 174 minus 3 times 8.95. You wouldn't know which one to pick. Divided by 8.95 and plus 2. And I got 13.44 inches. And now you can say, show me, because this is not enough. You should not trust that this gives a max or a min. You'll have to say, well, show me, and I will show you. I will only need to create this table with 8.95 inside and 0 here, of course. The denominator is always positive. I will not plug in anything. I will not waste my time. And when I go to the left and I plug in 0, 0, 0, negative with negative in front will be positive. And when I plug in 10, this is positive. This is 100, 300. It will definitely go over this. So this will be positive with minus in front. So this is definitely a maximum, up and down. In case we're asked to find the maximum area,